So welcome back to the fourth lecture on aircraft communication and navigation lecture series. Today we will learn about HF communication, that is high frequency communication. We will learn how HF communication occurs, what are the components used, what type of antenna is used in HF communication and much more. So if you are new to our channel, please subscribe to it to keep us motivated to make such videos. Well, the HF turns out to be lower than the most of the frequencies we deal with. Technology has indeed made the radios easier to use and the transmitted signals much clearer, but there are still a few things to be gained from learning the technical stuff behind the technology. The frequency range of the HF band is 3 to 30 MHz. Most radios use the frequency spectrum of 1.6 to 30 MHz, but long overhaul communications in this band takes place between 4 to 18 MHz. And also higher frequencies such as 18 to 30 MHz may also be available from time to time, depending upon the ionospheric conditions and the time of the day. Therefore, the HF systems may have up to 280,000 communication channels, which can be tuned at 100 Hz gapping and 16 programmable preset channels. Preset channels are simply channels that you can save or store as your favorite channel. Usually, HF communications are long-distance communication systems and are employed on all aircraft. Airlines utilize as per their requirements and they are not found on light aircraft. The HF systems consist of a control head or radio tuning unit in the cockpit, HF transceiver, coupler, and the antenna. The HF antenna, which was previously used on the aircraft, simply consists of insulated copper wire which extends from the aft of the fuselage by the electric motor to change its resonant length to correspond. Modern aircraft use either a fixed length antenna with a long wire extending from vertical stabilizers to a point on the top of the fuselage, or an antenna that is molded into composite panel of the vertical stabilizers or other aircraft surfaces. The antenna is connected with the coupler that matches the fixed length of the long wire by loading the antenna through a series of LC tuned circuits. The coupler is installed in the aft equipment compartment and tunes the antenna to the selected frequency. The HF transceiver is also installed in the aft equipment compartment and contains the transmitting, receiving, and processing circuits required for the operating of the system. The transceiver also interfaces with the antenna coupler to control the antenna tuning. It also sends the signal to the audio control unit for the microphone, headphone, speaker operation, ADF, and cell call decoder. The HF system operates in simplex or half duplex mode using these three types of modulation: amplitude modulation, lower voice secondary sideband, and upper voice secondary sideband. The HF frequency and the mode of operation are monitored through the RTU from the cockpit. Before transmitting, the antenna must be tuned to the selected frequency through the antenna coupler. The coupler tunes to the new frequency when the HF push to talk switch is pushed momentarily. During the transmit function, voice or data signals from the equipment are switched through the COM switching matrix to the upper sideband and lower sideband, transmitting audio inputs to the transceiver. A key signal is also applied from the equipment. For emergency or maintenance operation, voice and keying signals can generate at the mic or headset connected to the transceiver. So the audio to the radio frequency conversion occurs when the carrier frequency is modulated by the audio output. The modulated output radio frequency is amplified by the amplifier to the selected power level of 400 or 1000 watt, depending upon the mode selected on the control head. Then finally, this signal is coupled to the antenna for transmission. So I hope that you enjoyed watching this video. Well, one of the most usually occurring problems encountered with the use of HF system is that HF depends on the energy being deflected off of the ionosphere layer to achieve long-range communications. This layer changes in density and altitude depending on the time of the day. As a result, the frequency at which the sky waves are most effective also changes. So if you find the video informative, subscribe to our channel for more videos. Share it with your friends. See you all in the next lecture.